Well, thanks for everybody for coming today. We got pretty good turnout here. Woke up Saturday morning and looked in the mirror with one eye open and found I had the biggest zit I'd ever seen in my life on the end of my nose. So I knew it was presentation time. So IoT Hub. Anybody using it in production at this point? Anybody? So, yeah. Thank you. We've got one person there. Right. It's we've got a pretty big implementation that we just did, which is one reason we wanted to do this presentation. And I'll get into some detail on that. But nobody else at this point is, well, Event Hub. What about Event Hub? Any production implementations of Event Hub? Anything unusual? What kind of implementations have we got in production? Nothing really? Okay. All right.
People want to know if you're lying to them.
Yeah, this is great, man. Well, I don't even need the slide deck now. So I'll tell you what we're going to talk about today, and then we'll talk about it. First, a little bit about the IoT market. I don't want to spend a lot of time on that because we're not here specifically for that, but it's just booming, crazy booming. What is this IoT Hub thing? How do you talk to it? Will it talk back to you? You know. We're not going to get a lot fit in an hour. It's a huge, huge topic. I mean, it's not. IoT Hub is like the starting point for just tons of stuff. It's just huge. But we're going to kind of focus in on the IoT Hub part of it in some ways that you can use it. I've got an example that I just stole blatantly off the Microsoft site. And I've got, I think it was kind of 14,000 different console app examples that Microsoft has put out there. So I took one of them. This is message routing, though. I didn't want to just like send a message up, get a message back. So I've modified it significantly. We'll talk a little bit about the structure of messages. And we got a real deal Industry 4.0 implementation we got with a major client of ours, Service Thread. And I got a lot of stuff on that. And hopefully, I'm assuming we're going to want to focus some on that. Because the thing with this is it gives you an idea of what you're up against when you actually do an IoT or an Internet of Things implementation. And we found out there was a whole lot more to this one. We've done several, but this one was sensors right on machines, working with somebody's existing equipment. And it was not easy. It was very difficult to figure it out and to get it implemented. Because you can breadboard anything, right? And then the next thing you got to do is you got to package it, and then you got to install it, and then you got to make sure that it's, it was quite an effort. So we'll go through some of the details and trials and tribulations of that. As far as just IoT growth, I got this off of Forbes. It was from, I think, January this year. The link's down below if anybody wants the slide deck. They figured 2015 it was like $60 billion worth worldwide. And they think by 2020 it's going to be 270 or so. It's in euros here, but yeah, dollars. So it's like, this is just crazy. So people are trying to, and there's no real stacks. There's always different stacks. There's always different frameworks. There's always different devices, and they all just have little different needs. And that's one of the things we're trying to kind of specialize at logical end is how to match these things together, how to glue these pieces together, and which layers we fit into. But yeah, the growth is just crazy. So that much growth, 3 years from now, it's like a good market to be in. The biggest market growth is not. They figure that the sensors themselves and the microcontrollers, those are going to be commoditized. So they're going to be just like dirt cheap here eventually. It's the services and the getting that data in and doing something with it. The stream analytics, the BI, just general dashboards and things like that. That's a lot of where the value is going to come from. So that's the IoT market. So the Azure or the IoT Hub, it's an Azure cloud service. Seems like everything is some kind of cloud service at Microsoft. I believe I went to TechEd a few years ago, and they even said SharePoint was a cloud service. Visual Studio is a cloud service. So it's an Azure cloud service. As far as I can tell, there's no development environment locally. I've looked around. There was something on GitHub. That scared me to death. So you got to have some kind of a subscription in order to do this stuff. And they've got all different levels. We can get into some pricing and that kind of stuff. But you got to have something in the cloud to do the IoT Hub stuff. The IoT Hub itself is fairly new. I think it came in February of last year, so it hadn't been around a long time. And we started on the service thread effort, and I started using Event Hub. And Dan, I mentioned it to Dan. I think he actually slapped me. I think at the time, made me. It made me change over to IoT Hub. And it's definitely the right decision because it is tailored for IoT, and we'll talk about why that is, or how that is. So you can receive messages from devices. And what's a device? A device can be just about anything that can send a message in the right protocol. It really doesn't matter. So I'll have an example here today with a console app. It could be almost anything. Certainly things like microcontrollers that can communicate with the outside world, or can communicate with something that communicates with the outside world. There's some restrictions. We'll go over the protocols and things like that, but it could be just about anything. One difference, and we'll cover this in more detail too, is that IoT Hub can send messages back to devices. Event Hub is, as Microsoft says, ingestion only. So you can just suck them in with Event Hub. And you can send other things out, but you're going to have to code something else to do it. And it can ship all these messages and data off to all kinds of other places, stream analytics and service bus function apps, which is another interesting piece. So there's once you get that data in, then what you do with it is just the possibilities are just almost endless. And it's not just about like millions of connected simultaneously devices sending millions of messages per second. It's about communication to a central location from which you have a tremendous amount of flexibility with what you do with that information. So you don't have to just be blasting, screaming amounts of messages out. This is about a place to make all this happen that's easy to manage and relatively easy to code. My perspective, IoT Hub is not that huge a piece of all this. I mean, it's an implementer. It's an enabler. But what you do with that data, how you get it there, and what you do with it after it receives it are going to be a lot harder than using the IoT Hub itself. This is one that came out from Windows IT Pro. Kind of gives you an idea. This is real early. I don't think it had been quite released yet, but I notice they have over here that the devices are C# simulator. But gives you some idea. So you get stuff, it's like your entry point, or one of the entry points is IoT Hub. You can also have your own custom gateway. You can have a gateway in the cloud if you need some sort of translation of protocol. But once it gets in there, it's like stream analytics, it's storage blobs, it's wherever you want to put this stuff. It's just so flexible after that point, and it is fast. So some of the features, you can register each device. You have to basically register each device, and it does per device authentication. So you can manage these things. You can shut them down. You can throttle them. There's just all kinds of flexibility with these devices once you've got them registered. Certainly, you can route to other Azure services using declarative rules. I got an example of that shortly using messages or endpoints and routings. There is a portal for monitoring the devices. I find it highly confusing personally, but there is a portal dashboard there. A lot of development libraries, and just about any device like Raspberry Pi, they don't have a Python specific library that I've found so far. Somebody's made a wrapper for their C library. But I mean, if you can run Node on something, you can just plow right through this stuff. So there's just a lot of language options available for implementing this stuff too. And again, as they claim, they've tested this with millions of simultaneously connected devices sending millions of messages per second. And if you do that, it'll cost you some. Well, we'll get into the pricing in a minute. So here's just some numbers that I got off of the limits page. I got the link down there at the bottom. These were I thought were kind of interesting. So for device to cloud, you can save those messages up to 7 days for whatever you might need to save them for. Maximum size of device to cloud message can be 256K, or you can batch these things. So you can have a 256K batch and up to 500 messages in a batch. So, which I thought was interesting. I haven't tried that yet. But then you get on the cloud to device side, the other direction, then it's a little bit slower. It's almost like at home where you got your 300 megabit download and you got your a fraction of that upload speed. It's kind of like that. Cloud to device message, biggest can be 64K, which is pretty big though, really, when you think about it. I mean, if you're in this kind of realm, your devices are probably going to want little bits of data, not big verbose pieces. And they'll only hold a couple of those, or those for a couple of days. And you can also acknowledge. So when a device receives a message, you can return an acknowledgement too, so that it closes the loop. So a lot of these things are configurable. Those time to live or time to live numbers, for example, they're configurable. There's a lot of configurable pieces in this. And just as an aside, I'm not a script person, but you can use PowerShell to do an awful lot of this stuff. If you're a PowerShell ninja, then you probably are just going to go crazy at the command line with this stuff. I like to use the portal. I just like to be clicky. But there's a lot of flexibility in how you manage this stuff. So for the pricing, they offer the 4 different levels. One's free. It defaults not to free, but to the S1 level, which tripped me up when I was setting up this demo. The free level's good enough for experimentation purposes. They won't let you switch from free, so if you do something cool and free, you can't just port it over to S1 or S2, and you can't go back the other way either. So once you start with free, you're stuck with free. So they've definitely got some limitations there.
If you're on S1, can you go to S2?
You can do that. You can always scale up. Yeah. Yep. So here's the pricing is I thought was just fascinating. So they've got the total number of messages you can send a day. All right. So let's say for the free level, that's 8,000. That's not really how they bill that though. Right. Those are messages, like physical messages that you send up. But that fourth column, that message meter size, that's the key right there. So if you send up one message that, or if you send up, let's say you send up one message that's got 8K in it, you've just sent at the free level 16 messages as far as billing goes. See how that works? So it's in the fine print on this page. I got the page listed there. So it's the message meter size that is how they bill, not the total number of messages that can be handled by a particular level. But by the time you get to S3, that's quite a few there, 300 million per unit, and that's just per unit. That's going to cost you 5,000 per unit per month, and you can pick your number of units and that type of thing, scale it up and down. So that's the pricing. Comparison with Event Hub. I'd used the Event Hub a little bit before, which is kind of why I started out using it for the service thread effort. But there are really some significant differences when you get into this. One of which is that it's bidirectional. IoT Hub is bidirectional, Event Hub is not. State information, they got something called device twins that tries to keep track of the current state of your devices and make it available online all the time. It's sort of a metadata sort of a service. Protocols are pretty much the same, MQTT over WebSockets, MQP, so on and so forth, but they do have their own protocol gateway that you can modify for your specific needs if you have to do some sort of translation. Security per device, as I mentioned before, you can revoke access for a device, things like that. And I can just imagine if you got thousands of these, if you're using the website, they got a little query language you can do to find your devices and stuff, but it's pretty easy if you just got a couple. But if you had 1,000 up there in one group, it would be pretty interesting to manage. Say operate.
Public-private keys that are on both sides for security?
No, you've just got a.
TLS, right?
I'm sorry. I didn't hear the second part.
Azure says it's using TLS for security, which is PKCS, so it's using public and private keys. Are the private keys generated on the Azure side?
Yes.
Okay.
Yep.
So the device is given a public key.
Right.
Okay.
Yep. And you use the public key then for all the communication. Yep. All right. Let's see what else we got here. Operations monitoring. Digital device authentication.
But it was really cool at the Charlotte IoT meeting last month. A guy from Microsoft came from Seattle, and he said that they're experimenting with making their own microcontroller with a TPM in it. And with that, then you can push your bits down to it and know that it's secure from the device level all the way up through the whole platform. It would be really cool if they actually come to market with that.
Yeah. I just keep thinking about the Netduino. I don't know. I mean, I know what you're saying, but yeah, it would be cool. But for the service thread thing, we used a particle Photon, which was just an incredible little device. And it sounds kind of like that's what they're describing to a degree, except more customized for the Microsoft stack.
Yeah, exactly.
Yeah. So yeah, and I think there's going to be lots of things coming like that. But then the stuff is so cheap too. It's just unbelievable. We'll get into some details on that. Scale, it's like, millions and millions and millions. There's no problem with scale. Event Hub, man, not so much. I read somewhere that they've been tested successfully with like 500,000 simultaneous messages, measly 500,000 simultaneous messages, losers. SDKs, mentioned before, we got lots of SDKs available for this stuff. And endpoints. Endpoints is a difference too. So, and I've got an example of this. So you can set up endpoints using service bus queues, and then using real simple, sort of like where clause in a SQL query, have it go to these different endpoints, and then have your different devices or different whatevers listen specifically for the endpoint that the messages have been routed to, which real simple to set up, and I've got an example app that shows that. Speaking of which, so here's what the app is like, the example app. So it's just the device side's a console app, and it sends messages up, but it also, and it's got like a random number generated in it, and it's pretty much one of the Microsoft type samples, and but it also has a property. So the way the message is structured is essentially the payload is just a byte array. But it also has a properties property, which is a string dictionary, and you can add anything to that. You can add anything to the body of the payload. They're not real specific about what you have to include in a message. So I had a property called warning, and it's either true or false, depending on the state of this number that goes into the message body. It was funny too, and I added the one package to the simulated device thing. I think I probably got 200 references in other packages that came with that. I could not believe it. On the other side, I got like nothing. So it was still not clear on why there were so many packages required just to send a message, because there's like 20 lines of code. So I got two console app listers. One's listening for all the messages, and the other only listens for when this warning property is true. So I set up a couple of custom endpoints, and we'll look at this in Azure in just a minute. So IoT Hub, with the routing, I set up endpoints. You can have up to 10 per IoT Hub, and each one of those is going to require its own service bus queue to receive the messages. So then when you set up a route, then what it does is I set up a normal route and a warning route to match the normal endpoint and the warning endpoint, just to keep it easy. And there's a little bit of that where clause like logic in here. It looks for something in the message, says, oh, okay, I know where to send that, sends it over to the appropriate endpoint. So then you've got your whatevers listening for that particular directed, or really for that event queue. So you got a connection string that has at the very end of it, it's entity name, which is not referred to as entity name anywhere else, but that's what it is in the connection string.
Steve, you have 10 endpoints for IoT Hub?
You can. I mean, there's two default ones that you just like listen for everything, and they go, one goes one way, one goes the other. But you can have up to 10 custom ones too.
So 10 messages.
10 filters, essentially.
10 filters.
Yeah. And then each one has to go somewhere. I used service bus queues for this example.
So yeah. I think people are used to, with MQTT, having a ad hoc network where you can have any number of subscribers to messages that go to the broker.
Mm-hmm.
So is that 10 a limit on the number of subscribers to your messages, or is that just for this endpoint is something, a term that we don't understand yet.
Yeah, I don't know why it's 10, but 10 is the number of just endpoints. These are just endpoints that, and they're essentially they're service bus queues. Each endpoint is a service bus queue. So you can have any number of listeners, no problem there. So, but it's just a limit of 10 on how many custom endpoints you can create. I don't know why
You
it's 10.
typically would have a separate message for each endpoint, right?
No, you don't have to have a separate message. You just have to have data associated with each message that allows the IoT Hub to route it to that particular endpoint.
Okay. I was thinking of like message structure, but not even that.
Mm-mm. No, I use the same message and it goes to two different console listeners in the example I got. All you do is just change the value of a property. So the property is called warning, and it's either true or it's false. And one of the listeners gets all the messages, and the other one gets only the ones that are the warning equals true. So it's sort of a simulated alarm sort of a scenario. So yeah. So let's take a look at the portal. I can find that guy. Nope.
Can you blow that up, please?
Yeah. Yeah, let me find it here. I wonder where I put that. Is that it? Put it out here so it would be easy to find. There it is. All right, so let's go up to the top level here and I'll blow this up a little bit. So this is the whole setup, really. These are the only two resources that are involved in doing this. So I just created an IoT Hub, which is really straightforward. And then, of course, I had to do the service bus, so I could leverage the queues for the routing. So if you look at the property of the IoT Hub, or the properties, so the key things there with the routing is that you establish these endpoints. And I've just got 2. You can have up to 10. It gives you a little warning right there. You can have up to 10. And so one of them's called warning endpoint, the other's called normal endpoint. And you have to have a service bus set up already, and then you just use service bus queues for each one of these guys. So then to distinguish what goes to which endpoint, that's where the routes come in. So if you look at these routes, I got 2. One's normal, one's warning. And it's as simple as this. So in this case, I said, yeah, true or false, send them both. I could have done that a different way, but I was playing with the routing. But the other one, the warning, just I only want things where warning is true. Warning is a property that I added to the message. So it's really as simple as that. So at that point now, you've got automatic routing of these messages. Same messages, but they can go to different endpoints for different listeners. And let's see if there's anything else in here. That's really the main thing. The other thing is just the service bus. So I've got not much going on in here. Same sort of thing. 2 queues. One's the normal queue, one's the warning queue. So once you know how to do this, it's pretty easy. Some of the examples are a little hard to follow, especially with the connection strings, but on the IoT Hub side. But that's really it. So at this point now, I'm able to receive an unlimited number of messages or route them wherever I want to based on some simple logic and that type of thing. So back to the presentation. And now for some code. Should have closed everything except what I needed. Let's see here, where's the code? All right, so here's what we got on the code side. Let me just blow this up a little bit. I got 3 console apps over here. So the main one, or the one where the most stuff is the one that actually sends the message. Is that too big, or can I make that a little smaller? Okay.
It's nice.
It's nice. It feels good. So This is the one I was telling you about, that I added one package to this console app, and this is what I ended up in the package list here. And it seems like a lot for like 20 lines of code, but it really felt like it needed all that. But in the actual code that sends the message, there's not much going on. So it's the usual stuff. I got a few things up here. It's all static. Get a couple of things like the device key and the device name, which you register up in the IoT Hub. And so you got connection strings that make that happen. Then all you got to do is create an instance of device client, which is right up there in the namespace you would expect. Maybe I'll hit F12 instead of deleting characters. So it's up in the Azure Devices Client namespace. Pretty logical. So what you can do with that then is once you tell it a little bit of startup information about it, all right? So in this case, it's with a symmetric key, MQTT. That's all configurable whenever you create the device. It's MQTT by default, I believe. I don't know that you have to specify that. So then there's the registry information from up in the cloud. They call it the registry. Unfortunate choice of names, I thought, given the old registry. So this guy just wants a second. It goes through. I figured, like, if let's say I had something that measured my brain activity. All right, so while I'm working, I don't want it to get below 20%, you know. But I'm thinking I don't really want it over 60 either. All right, so if I can monitor that, then maybe it'll give me a little slap in the face if I'm below 20, or give me a shot of Red Bull if I need it, and that type of thing. So it just picks a random number and spits it out between that range. So message ID, this is all arbitrary. It's just an anonymous type here. There's nothing fancy going on here at all. I could have put anything in here, or I guess nothing. I didn't try it with nothing. That'd be kind of pointless, I guess, but I probably could have put nothing in there. So it's an anonymous type, and I just got message ID, device ID, and brain level activity. So, and then I added to that, well, then you put it in JSON, and you turn it into a byte array, and then it becomes essentially the message, the real message. So now you can add properties to that using this. Well, you can add values to this key name pairs, key value pairs, because this is an actual property of a message. So I added that just for fun. But this message properties is actually a dictionary of string, and you can put pretty much whatever you want to put into there. So in that case, depending on what the level of brain activity was, is either going to be true or false. So that's how I set whether or not this property is true or false. So then after that, you send it. And that's pretty much all that's going on. So there's not a lot of code involved to make this happen. You can, like I say, you can put anything you want to in this message body. You can add arbitrary properties to the properties dictionary. And there's a few other properties that go along with it too. And then you send it. That's about it. And then it waits for a second, sends another one. So these receivers, not a lot going on here, that's for sure. So we just set them up to connect. And this one has more going on. So it's actually listening for an event. You see a lot of these examples where they put it in a tight loop. It's like an endless loop. It's like, oh, come on, don't do that. So this guy is it's listening for something to happen. And so when it comes in, it just does the usual stuff. Takes it as a stream, it decodes it into an object essentially. And then I do some stuff to make the console pretty. And that's pretty much it. Then it writes out the message body once it's turned it into a string. So then the other one, so this is the one that listens to all messages. So if you got a warning message come in, it's going to be red. If you got a regular message come in, it's going to be green. Then the other one listens only for warning messages. So it's really simple. There's not much going on here at all. It just spits it out to the console and some color. So if I run all this, so this is the one that is sending the information. It'll get going here in a second. Yep, there we go. And the very first one, I've got brain activity problems. So this is what it's sending. And this is the message body, pretty much the raw JSON message body over here. So as you can see in this queue up here, it's only the things that are warnings, that have that one property that's added as a warning and set to true or false. And this one's getting both. So you can kind of imagine what you can do. That gives you a lot of flexibility in how you can pass these messages around and not flood one just to make decisions about what it's seeing. So for example, you could also use a function app. And so the function app would receive everything, and then it could make decisions about, well, this was true, this was false, this was red, this was blue. But you got to write all that logic. So this at least takes a lot of that out of it, and it really simplifies it. You can still use a function app, but this is a lot simpler in this implementation. No, it's all about sending. It's not the receiving part of it. Yeah. So that's what it does. So just keep sending them up there. I'll just keep doing that. Keep charging me. So, and then if you have a device twin, that additional monitoring piece, it costs you extra. I mean, you really got to watch the costs on these things. You know, it's sneaky. That message metering thing and all. But it's really not that expensive. I think that service thread, it's pretty surprisingly inexpensive, as I recall, and we were sending a lot of messages.
I'm curious how close it is to what we predicted.
Yeah, I think the last time it was pretty close. It was darn cheap, really, when you think about it.
I was worried about that.
Yeah. So that's just a real simple example. So now we get into a real world example. Okay, so this is what we did at Service Thread. Service Thread is a company that essentially winds specialty thread for industrial and then other specific. It's not going to be something you wear in your shirt unless you're a fireman. I'll put it that way. So it might be like fire hose covers, things like that. So it's all specialty stuff. So they've got all these winders. So every winder can have, I think the lease is like 12, and they can have dozens of these spindles on each one of these winder machines. And every one of those spindles really could be considered a different machine, right? So everyone could be spinning a different type of thread at the same time. So what they're really concerned with is that if a spindle's not running, it's just like a machine tool not running. So they're not making a product. So what they want to do, and they have a lot of reasons for doing this, is quantify the uptime, downtime by machine, by department, by type of machine, by shift, by product, by all these things. And what we've done has made that possible. Just writing the reporting side of it that Carolyn's working on is a tremendous effort. You know how that goes. It's going to grow and grow and grow over time. But it's given them the information that they've never had before. Some of these machines are literally like 100 years old that have been retrofitted with PLCs.
I forget it was like pre-World War II.
Yeah. This is not new technology.
So, I thought it was really cool. We connected it to this really old machine that previously didn't even have a PLC, and then they upgraded it to a PLC, and now it's like online, and they get real-time data.
Yeah, exactly. Yeah. And so each one of these spindles, and so what we did, and this is all Dan. I was just the implementer here. Dan had all the ideas. But every spindle is monitored by an inductive proximity switch, right? So it senses metal. When a piece of metal passes by within a certain distance, it goes, oh, yep. And it just sends that signal back up to the PLC. So then the PLC does whatever it needs to do with it. And so Dan's like, well, it's just a proximity switcher. We can hook anything into that. So then the decision became, well, what though? So then the data requirements were, like I said, it was we record the state of each spindle, whether it's on or off. That's all we're worried about now. We can get RPMs if we need to. This microcontroller is so fast, it's unbelievable. But right now it's just on or off, and we report once a minute, and then that tells them what they need to know over time, how long were these spindles operational or not. And because downtime is just money to them. So then it finally makes it all the way over to Cloud SQL, Azure SQL, and there's a lot that goes on in between that. So I mean, this full stack of this thing. This is really cradle to grave. This is the full gamut of an IoT project. It uses IoT Hub, So, and then at the end, they needed the setup to be really simple. So if they want to bring another machine on and hook it up, they need really simple setup instructions. And most of all, they don't want us going down there, and we don't want to go down there either. It's in Laurinburg, put it that way. So this needed to be really simple, really intuitive. These controllers needed to be inexpensive or whatever we used. I mean, there's a big decision process just in what to use. So one thought was just, can we just program their PLCs? Wow. You know, I'm just so glad you guys decided not to do that. You can just imagine these machines might have, most of them were Siemens. They had the same Siemens logo model PLC, but my God, you know, every machine might have different requirements, and what if you screw something up, you know? You have to learn all these different languages for PLCs, and, you know, it was just like nuts. They don't talk to the network. You know, the logos, all you could get was RJ45 or a cell card, and then you'd have to translate what it said into something else, and yeah, it's just nuts. So, well, what about some black box? Well, what? You know, so then we still have integration issues with all the different types of PLCs and things. So then we thought about the separate microcontroller, and this is all really Dan's thought process. But then there's like a bunch of questions with that. Can we connect to existing proximity switches and not mess up the signal that's going to the PLC? And, you know, divide the voltage somehow and then mess that up. Yeah, what if the connection impacted the signal? How would we power it? What's available inside the panel, the control panel for the machine that would allow us to power the microcontroller, whichever one we picked? Which one should we pick? Couldn't be very expensive, we knew that. And how many would each machine need? So we looked at some things like some PLCs that only had like 4 inputs standard, and it cost you another $100 to get 6 more or 8 more. And I was like, oh no, that's too much. So, so then how much would all that cost to add to the project? And so what will we do? What will we do? So what we ended up doing was using a separate microcontroller, connecting to the proximity switches, just like I described there, report to IoT Hub using Wi-Fi. And but you know, as far as all those questions go, all those things, it just worked. Dan picked this particle Photon. It's got built-in Wi-Fi. It's got up to 18 digital inputs, which is what we needed to that. They're all configurable. Any of them can be analog or digital. It programs in C. Pretty easy to program. Especially if you're a C programmer, you could have done it half the time I did it, that's for sure. What do you mean you can't add a number to a string? That doesn't make any sense. And it cost $20. I mean, these things are $19.95 on Amazon. If you got Prime, there's no shipping. Oh, I got one here. I'll pass one around. I don't believe how small this thing is. I got some other pictures too. I haven't opened it yet. Fresh out of the box. Well, I'm not going to do that. If anyone wants to open it up, pass it around.
You gotta put a disclaimer up there, not actual size.
Yeah, yeah, it's way smaller than this, that's for sure. So but it's got all these input-output pins available on it. It worked on, I think it was like up 5 to 9 volts or 3 to 9 volts or something like that.
3.3.
Yeah. Most of the inputs would take most of them were 5 volts they could take, which became
You can only take 3.3.
3.3, which became kind of an issue. So, and this is the kind of stuff that you run into when you're doing a project like this, especially brownfield. The PLCs would put out gladly give you 24 volts of DC, all right? Well, these things won't even close to take 24 volts. They'll just explode. Well, no, they just won't work anymore. So we had to get an opto isolator in between. And that was a challenge because we found something online, and of course they were only available in China from Alibaba. And it took about 3 weeks, I guess, to get the first ones. And we didn't even know if they're going to work. So, yeah, so it was a cakewalk, right? Oh, no. So the prototyping, that was fun, too. That thing on the table back there that's all prettied up now with the spool of thread on it and everything, that started out looking a little bit different than that. Here's the opto isolators that we ended up using. And they've only got 8 inputs each, so we could only do 16 on a machine. So instead, we got 18 inputs, but we had 16 available. About to fix all this, though. I'll get to that in a minute. And the programming, we had to figure out what the flow should be to set these things up and put them in run mode and make it as seamless as possible and all that stuff, just with the little bit of code you can do with the microcontroller. And the mounting and wiring, well, that was fun right there. Just wiring the opto isolator to the microcontroller, and then from the opto isolator to the patch panel and the service box, you know, to where every one of the inputs from the proximity switches came. That was me and Dan for a whole day doing that.
That's fun.
That was pretty cool, yeah. Because the main thing was at the end, it just worked. So this is what the prototype started out with. I made this over a weekend one time. And I thought, you know, I even put some Danish oil on that. Look at that. That's beautiful, isn't it? It was gorgeous. And what it ended up looking like was this. So, because what we needed a whole bunch more inputs than just the one, and we needed to test the speed. So the first one we could kind of spin it around a little bit, and it'd get a signal, it'd do what we expected it to do. And then we were talking on the phone one time and thought about, oh, what if we hook up 18 signals and they're going a couple of thousand RPMs, you know, at this radius with a little tiny button that's passing so fast in front of the sensor, is this microcontroller going to handle it? So then I went back out in the garage and tore the pretty one apart and put a bunch more sensors on that guy, and put a stub at the top of it where we could drive it with a hand drill. So, and it worked. The first thing we found out though was it didn't work. It wouldn't keep up, and it turned out it was because these $7 proximity switches I'd ordered from Amazon had like a 2 hertz response rate. Right, so we were thinking it wasn't keeping up. So then we got some $60 sensors, and it's like, oh, okay, we're back in business now. That's what these are. You can see them lit up there in the ends, and yeah.
The machines already had the sensors on them too.
Yeah.
All cheap ones for a prototype.
Yeah, and we figured, yeah, this is ground. We were saying, well, why are they paying like $120 a piece for these sensors? They're only $7 on Amazon.
You probably could have gone to opto-reflective instead of inductive.
Well, and we thought about other things too. Like we thought about things
See
like.
a difference in reflectivity of the metal passing.
Mm-hmm.
Yeah.
I thought about even taking like a 555 timer and just simulating the signal too, you know, and or multiple signals. But so we wanted to simulate the real environment. So then we ended up using the actual, not the same ones they used, but the same response rate that they had. So yeah. So this is really about IoT Hub. So it just worked. And this is what the installation looks like. So this part here, this is a host board with screw terminals for the Photon. That's the Photon right there, the little tiny guy. And I think this was when we got the first one working, wasn't it? Mm-hmm. And so what you can't see, if it was a video, you'd see all these little lights here just flashing like crazy. And it was just after a day of.
The machine's running so fast you don't even notice the lights are turned off.
Yeah, exactly. Yeah, just sort of a jitter in the lights, and that was a pretty good moment when we turned that all on and it started working, sending data up to the cloud, went to the SQL Server, and the whole bit just worked. Which is something I'll mention too, because now we got to do some maintenance on this and add some features. And we've got one IoT Hub, we got one of everything. So now we've got to duplicate that environment. Didn't think about that up front, because I'm not going to play live, you know, with changing the code on these microcontrollers. So we're going to have to duplicate that environment. That's something to keep in mind, though, when you're doing that. You might as well do that up front. So, but yeah, that's what it looked like. And here's the path. Here's the path. So what we had to do with this guy is the Photon microcontroller only talks to the particle cloud. So a company named Particle manufactures this little microcontroller. I think there may be some libraries in the works that will allow direct communication, but
yeah, they could talk directly via MQTT, but we chose the cloud integration because it was easier for the prototype.
yeah, and it was definitely easy.
Now, is Particle doing something for you in their cloud, like you have to pay them?
Yeah, which we would have to, not to route messages, but we would pay them anyways to maintain the firmware.
On scale.
Okay.
That's when you convert to a product, right, Dan, is what you're talking about, and then you can, in scale, update your devices.
Yeah, I mean, part of the debate that I'd be an advocate for in Charlotte IoT meetup is all this stuff is open source and it's pretty much free. So as soon as somebody puts their label on it and you start using a service broker that's in the cloud, you're paying for not only the product, like buying a particle for $20,
Mhm.
but then you also have support. You can call them up on the phone. There's probably
There's huge value. I don't care about phone support. We would never call them. But the value is being able to update the firmware and not having to build that yourself. You'd have to build a way to bring the bits down and to flash the board and to do that yourself.
Mhm.
So that is built into the
Yeah.
microprocessor technology that's off the shelf that isn't part of the cloud. But
Yeah,
you
there's
have
still
to-
infrastructure. You have to build
program
the
it.
cloud
Yeah,
part.
You definitely would have to provide your own, and then you have to do the security, which securing this stuff is not trivial, but I don't know that particle clouds locking that all down with high level security either.
Yeah, well, through TLS, and we put the microcontrollers on a whole separate network from the rest of the enterprise. Am I still in any of your thunder?
No, go ahead.
So basically, they've got 3 networks at the company. They've got the enterprise network with all the servers. They got the guest network. Then we have our IoT network. It's totally separate from everything else.
Mhm.
And so the whole purpose is if you were to hack one of the controllers, well, what can you do? Well, you can't do anything to the rest of the enterprise. And you can't do anything to the machine because it's just monitoring the same sensors. It's not controlling any of the machine. We still have the PLC logic controlling the machine. And so we thought that this inexpensive microcontroller that's already connected to the cloud would have a much cheaper implementation. There was a lot of design we didn't have to do because they have 3,000 spindles and then we're done with that implementation. It's not like we're making millions of these where it would be worth the investment to put in our own over-the-air update infrastructure to update the firmware and things like that.
So maybe get level set people who aren't familiar. Some of the things with IoT is people are going to businesses and they'll see a security camera and they'll hack the security camera. They'll be able to hack the security camera and it'll be on the same network bridge to laptops in a corporate center or whatever. Or in your house, you'll only have one NATed router and all of your laptops and stuff will be on the same router with your cameras and your door sensors and what have you. So what Dan did was separate that network out so that you're not dropping lines.
Yeah.
And I don't know whether the entire room knows about that or not.
Yes,
Mhm.
and especially in an industrial environment, people are really scared. You're going to come in, you're going to stop the machines from running, or someone's going to hack it and get data they shouldn't have, and things like that. And so by putting it on its own network, and we also isolated the monitoring logic is isolated from the control logic. So you can't hack the machine and do things to the machine. It's separated that out.
Yep. You're talking about like those Chinese cameras that were all on a mesh network, and
Just phone to home.
yeah, that's great. Yeah.
Yeah.
Yep.
Recently, the university was supposed to was shut down because of new smart lights.
Smart lights. Wi-Fi?
Well, we were one office. Off the topic, one office I was in, was just looking at the network one day, and I saw somebody's thermostat on the network, and it hadn't been secured yet. So I called the network guy over, and I said, "Should we? I mean, we could have claimed it right there, but we didn't. Darn it." So, but yeah, so this thing, it communicates with the particle cloud. And I will say, as far as I recall, it disappeared once. I mean, that's a valid point. This is a free service. It disappeared for several hours one day. Don't know what happened, that type of thing. But it's only happened once in several months.
We debated not going to particle for the pure instance of going through their cloud as a step on the way to IoT Hub. But since they also support MQTT and anything Arduino supports, then we knew we could go directly to IoT Hub. Even if they don't build an API directly for IoT Hub on Particle, we can do it through MQTT. Be safe.
Well, and also you want to do the air programming and you've got that and you're paying them for that, but you don't have to use their cloud to do the MQTT, right?
Right.
So you could have just dropped off their network and onto the Azure.
And we still can. It wouldn't, Steve could make the updates from here and push the code, and now it's no longer integrated through the Particle Cloud.
Yeah, the nice thing about the particle integrations was they just had come out with them for IoT, And it literally was like I made 3 or 4 entries in a web page and it just worked from that point on. As far as latency goes, it goes through all these steps. Some processing involved, finally ends up in the SQL Server database, and I don't think I've ever seen it take more than 3 seconds from device to SQL Server database. It's just incredible. But it goes up into the particle hub, the messages do from the microcontrollers. And that hub then has this integration, this IoT Hub specific integration, forwards it on to IoT Hub. And from that point, we've got an Azure Function App that's listening. So it's set up as what's called an Event Hub trigger. And so it gets all the messages that come through IoT Hub. And it's an application that you can add C# functions to, if you pick C# as a language. So it's got a fair amount of code. It's the worst programming environment I've ever seen in my life. They give you this thing up in the cloud. There's no IntelliSense. There's no nothing. I mean, it's just, well, you get color syntax highlighting. Thanks. But that's it. So I ended up having to do a lot of it locally and simulating the message traffic. But it works like a charm, and it's obviously pretty fast. So you go through the Azure Function App, and then the Azure Function App is going to write to SQL Server, and then we've also got a web API piece that we use for some of the communication. So I'm getting into that. To set a device up and make it really simple, what the device does when it first comes online is it automatically goes into setup mode and it starts blinking red. And during that time, it has sent a message up to the cloud, and it hits the Function App, and the Function App uses its ID, checks in the database, and then returns either a color or nothing. And if it gets a color back, it knows it needs to stay in setup mode, and it displays that color. So we figure if there's like somebody setting up several of these at one time, they're standing next to the machine, which one's mine? Okay, it's the purple one. All right, so it displays that color. So then what happens from that point is we've got a piece of a handheld app that Carolyn wrote that they can go into Photon Setup, and they'll see any that are in setup mode. They'll see them right here and what color they should be displaying. Then they can select the one that they're working with, and then all they have to do is enter some information about what machine it's associated with, and, the starting and ending spindles, because some of these have more spindles than one microcontroller can handle. And that's pretty much it, starting and ending spindle. Click Save, and then it sends a message back, because the Particle IoT integration will not send messages back. We directly communicate with the Particle Cloud until I go ahead and run. And from that point on, it's set, done, runs. Starts sending data immediately.
So yeah, the beauty is they're a maintenance technician. To provision a new controller, he goes to Amazon, he buys one, he gets our PCB board, he plugs it in, provisions it to the network, and then goes into that Angular app that Carolyn wrote and says what color is blinking, and then it's on this machine, and it's this spindle, monitoring these spindles. He does it himself without calling us.
Mm-hmm. Yep. And
so
if
they can literally expand their.
Right, they don't need us.
They don't. Okay, and now your back end is just scaling because it's all basically 3-tier messaging, right?
Mm-hmm.
Okay,
Yeah.
so you're using Azure Function. Do they remain in? Do you know whether they remain in the 3-tier?
No, we're not doing the free tier for the enterprise thing. He just did the free tier for the demo today.
Well, so there was a trying to talk on the Azure Function, and some of the guys talking about it said that the business went from paying Microsoft Azure to run like a little VM to not paying for any services because their messaging, their back-end function calls
So light, yeah.
was so light that they never reached the million message mark for the month that they cost anything.
I really think that Azure Functions and AWS Lambda, those types of things are like changing the way computing is going to be done in a lot of respects, where you don't have to think about, I don't need a server hosting this, I just need to be able to call this code somewhere, and you don't care where it's run at, and so it's kind of changing the way you think about apps and things like that. And
I think the only issue for us looking at that at scale is that, like running a Python program or a Node.js program, or in Microsoft's case, a C# program, what
we can talk about that, but I don't think we noticed any latency, nanoseconds. I mean, I don't think.
Yeah, it's
It can't be nanoseconds. It might have to stow, like in AWS's case, I don't know Azure, but no, it's got to run a VM, and it might have to actually schedule a VM. Now, it's got millions of these things, just to run a little Python your lambda function. But you have to get scheduled on it, so it has to decide, yes, I can run on this machine. Now, if you're already in their cache and running, it just hits it instantly.
But, and it's queued up in the event hub too, so that if you had messages stacking up, you can stack them up. So we wouldn't even notice it.
all right, and we do have the original timestamp from the microprocessor or microcontroller on there too. So we
So you can actually, are you taking multiple timestamps, like the other timestamp coming through the function, Azure function?
no, I tell you what I'm doing so far is because it's never been less than 3 or more than 3 seconds, and it's
Okay.
usually 1.5 or 2. I get it at both ends. So I capture it when it hits the SQL server after the insert, and I get it as when it leaves the
That's 3
microcontroller.
seconds from device through particle.
That's
drive through
everything,
IoT Hub.
everything. Yeah, less than 3 seconds. Yeah. So, but we'll see when we start scaling it up because we want thousands of these spindles online here. Now we're not sending with tremendous frequency once a minute, but as you get more and more of them, obviously there is more traffic. We'll be trying to minimize the message size and the whole thing. So,
Hey Steve, how
Yeah.
do you know when one breaks?
Um,
The spindle stops spinning?
yeah.
Anything, any alerts?
So there's a kind of a problem there. Well, yeah, we do. I mean, yes and no. So if it just stops, then because it always sends a signal, or it always sends a state of every spindle. So if the spindle's not operational, the state's 0. So it always sends that state. So we know if it was on or off. We don't know why it was on or off. But then they also have maintenance records that should be able to tie to that time when they start doing reporting and things like that.
Now it's in Azure, we can easily use Notification Hub and send a push notification to a phone if we wanted to, or we can do whatever we want. It's just the client doesn't want us to do anything yet. They want to just
Right.
accumulate data, and then let's figure out where we can get the value after we've accumulated it for a while.
Yeah, and then the other thing is we had one that just vanished for a few hours one day, and so we're coding in a piece that's going to attempt to reset it. Either if it can't send a message to the cloud, it'll reset, or there's going to be another thread watching something that will tell it that it's just not, something's not working here. This hasn't been reset. This value I'm still alive value hasn't been reset. So at least so it can, and then we can have it just reboot itself, that type of thing. So those are the things that that we're trying to put in place.
Yeah, reboot fixes like 99% of the problems.
Sure does.
When it's a microcontroller like this, it's not like they're loading a big operating system on it. It just reboots and it's ready to run.
Yeah, it's real quick. So, but if somebody turns the machine off, well, all we know is that we're not getting data from that machine anymore, and that's accounted for in the reporting because it's a gap in performance of the machine. So that's pretty much the logic flow. Once it has been set up and associated with the machine and that type of thing, that it starts up, it goes into that automatically setup mode. It looks out there, the Azure Function App checks the database, lets the microcontroller know that it's ready to run, and it just starts running, sending data back. So it seems like a pretty long way to get there, but I'm still amazed at how quick it is. So.
It's really cool. Once you start to have data, you can start to think of other ways you can get extra value from it. Like we wrote a work order system for the plant, I don't know if it was 5 years ago or sometime in the past. And so we know what machines fail, we know what spindles fail, we already have that stream of data. So now we've got the uptime stream and we have the fail stream. We try to look for correlations and then we could go to machine learning if the client wants to go there and have it make a prediction that this machine's going to fail within a certain period of time. Let's schedule a work order to get it fixed before it fails.
Or if a production schedule is available, we can see that it tends to fail more often when this particular product is being used on these spindles and that type of thing too. I mean, it's just the imagination is the limitation really at that point.
Now, logistically though, your network isn't tied into their network, and you don't know what they're running on the spindles, right? You have to add something to it.
Exactly.
All right.
We which we also wrote their manufacturing software.
Okay.
So
Yeah.
it wouldn't take much.
So you know which machine, you can go into the database, pick out what the product is and correlate that.
Yeah.
Yeah, that's Carolyn who's on the phone. She lives in that world.
Any other questions? I think that's it. Yeah, time for discussion.
Got one question, one
Yeah.
comment. The question is the host board that you had, is that something you developed or is that
Oh.
off the shelf?
Let me go through a little detail on that. I did mention that the opto isolator boards we had to order from China. That is made by a company called ControlEverything.com. And I think it's $16 or $18 or something like
It
that.
was like $750 each. Oh, you talking about the
Yeah.
website board?
Yeah. Yeah. So, but it's got multiple inputs instead of just a USB input. It's got several other features that come with it too. And the main thing for us was the screw terminals. So, but yeah.
What we're building though, what we did, that was for prototype, proof of concept. Let's prove that this works and that it kicks ass and it's awesome. Now that we've done that, we're making a PCB board, and it's going to have a switching power supply, and we're going to plug it into the power of the PLC, which is usually 24 volts. But if it's 12 volts, it can handle that. It'll step down the voltage to 3.3 volts, which is what we need for the microcontroller. And we'll have the optical isolators built into the terminal blocks. And we're also putting headers on it so that we can plug in daughter boards if we want to add functionality later that we haven't thought of. That each pin will go to a pin in the microcontroller. Because who knows what we're going to think of in the future that we'd like to do. Maybe we want to have a relay that turns on a little beacon light or something saying the machine's down. And we could easily add that functionality without scrapping what we already have.
Okay. The other thing I wanted to comment on is cost in Azure. So we have a production IoT product that is ultimately going to generate a few hundred gigs of data over its life. And so what we did was we stored the raw data in table storage, and then just did the summary data roll up for the reporting in SQL.
Right.
So that way the cost of storing that data is far less. The
Much
table
less,
data is
yeah.
A fraction of what the SQL data is.
Yeah, exactly. Yeah. Yeah, good
That's
point.
something that somebody can do if they have a lot of data or a lot of devices.
Yeah, and we're generating, was it 300,000 records a day or something like that? So,
we were going to maybe address that.
yeah.
SQL storage maybe is not the best place for it.
Right, and that is the most expensive element
Well, are they
right now.
on-prem with their database?
No,
It's Azure Cloud or Azure SQL. Yeah.
Yeah, so the message has one JSON structure that has all 16 spindles on it, and then we parse that and we write a record for each spindle. Was it up or down for that minute? And so that generates like 300 plus thousand records a day, which can grow pretty fast.
Once you split that out into individual rows, yeah. Yeah, and we're still at this point, we're logging every one of the messages that come in. So we see the raw delivery too. So we'll stop that before too much longer.
But you realize you don't have to put the messages in raw into your database, right? You don't have to use all that space. You
Yeah,
can
we don't.
compress them,
Yeah.
compress them into counts or statistics or whatever, right?
What we mainly were doing with proof of concept, let's
Yeah,
this
that's
works well.
we're now to the point where we can think about those things. You know.
I wouldn't put it all on your back end because your hub, your IoT hub, can compress those messages down with one of your Azure Function Apps and just say, hey, I'm collecting statistics. It just runs a trivial database, like a little memory circuit, and it's just counting and averaging over time, and then giving you like a little average of.
Yeah, I'll put it this way. At this point in the process, when we turned that on, it worked. We probably couldn't have cared less where we were saving that data, to tell you the truth.
I think what Dan was saying about the machine learning on the edge, the guy who came in, was that a lot of us are looking at, Microsoft would love for you to host all of your logic, business logic and whatever in their cloud, but a lot of us are going to put a lot of intelligence in the edge computing of our networks. These devices just spend time routing packets, and they can do a lot more for us.
Yeah, I think there's going to be an awful lot of hybrid work in the future. It's
Microsoft at the Build conference just announced too that they have an edge product that you still build your models for machine learning up in the cloud, but once you have your model, there's no reason why you can't make the decision locally. What's my prediction? You can make
Mhm.
that locally, and that's what you do in the Edge product. So the Edge product is an API to the cloud. It's not like completely independent from the cloud, but it does make decisions on your side of the firewall, and you can, if you don't need that, if that 3-second latency is too much, and you want to shut down the machine or do something, then you can do that locally.
Yeah.
Is there an amount of time when the unit goes down, or say the carrier network goes down, network 3, as it was described? Is there an amount of time that the data is preserved if it can't call home?
Yeah, we were talking about that. Yeah.
We talked about making a local queue, but
Yeah.
in the interest of getting something working fast, we didn't. So we did this whole project in, I think, was it 2 months?
Yeah.
And it was with Steve and Carolyn. Carolyn did the web components of the Angular app for the setup application. And Steve did IoT Hub and the firmware. And then I was just kind of like overseeing it and giving advice and things like that. I wasn't massively helping on the project other than some strategic things. But they did it in about 2 months.
Yeah. And it worked. Anything else? All right. Well, there's probably a lot of food left. I'd grab some of that. Other than that,
If you haven't registered for tonight's meeting, make sure you do it at Charlotte IoT. It's going to totally rock. And even if you aren't going to go, register anyways, because we'll get the count over 100. It'll make us look really cool.
You're just trying to make the building mad.
No, the guild meeting is the 4th Tuesday of the month, and I'm speaking at it this month. So it'll be a great meeting.
Guys, all this and humble too.
It'll be focused on IoT and Industry 4.0, some of what you saw today from a different perspective, and then also around home automation and a whole bunch of fun projects I've done.
Need to get them to stream too.
Get down where?
You need to get them to stream.
Oh, yeah, we need to stream the guild meetings. Yeah.
Yeah, I'll have to take that up with Microsoft.
Okay, with the network.
Sorry, Carolyn, you're just gonna have to come down here.
That's another thing to mention. If you can't make the Charlotte IoT meetings, we stream the meetings. And the other cool thing about streaming the meetings is on YouTube afterwards. You can like watch it over and over again. And if there's something you didn't quite understand, you can just go I think I didn't follow it too far. I think so. I think it's Crystal. Yep.
do you watch those over and over again, Dan?
Yeah.
You know, the nice part is that we're affiliated with Hackster.io, and
Yeah.
the Hackster people have watched them, and they were watching when Microsoft came down, because that was like their dog and pony show, that they were like, Microsoft was poking them, and then they were poking us to get the program out, and they were really happy to be able to see his presentation live while
Oh,
we were
yeah.
watching it, and see all the people with it, so that was nice.
Yeah, that was really cool. And in 2 weeks, we set up the meeting, and we got over 100 people to show up. That was pretty awesome.
Dan's got a lot of contacts.
Well, no, I was out of town, and Mike made it happen.
I didn't do anything, I just asked people to help me.
Well, you got the meeting going. So, yeah.
Thanks, Steve.
Yep. Thanks for coming, everybody. Appreciate it.